S is a set of alpha beta in R cross R. So alpha is also a real number, beta is also a real number, such that they have given that this limit goes to 0. Now, which is the following option? Basically, they are looking for what is the possible value of alpha and beta. So let's look at the limit then, okay, because my answer lies here. So limit x goes to infinity. Let's look at the term by term, okay. Sine x squared, okay. What is sine x squared? It's a finite value, right? Okay, what doesn't matter what is my x square. Okay, sine is always a finite number lying between -1 and 1. So basically this guy is not taking everything to 0 for sure. Okay, now let's look at the other one, sine 1 by x square. Sine 1 by x square, as x goes to infinity, 1 by x square goes to 0, right? Now if I have this also in the denominator, do you think what is this limit now? Limit x goes to infinity, what is this? Do you agree with me that it should be 1? Yes? If not, then think about this. Okay, you might have seen this earlier. Limit alpha goes to 0, sine alpha by alpha. Do you remember that this is 1? If you still don't agree, apply L'Hopital's. Okay, you will get this limit value to be 1. Okay, exactly with the same reasoning, this limit should be 1. So that means that I can just completely disregard these two terms, okay, sine x square and sine 1 by x square, if I have 1 by x square in the bottom. Okay, now let's write the remaining terms here. Okay, log x to the base e power alpha, that's my remaining term. Okay, if I have 1 by x square, that means my x power would be plus 2. Okay, because I have divided the denominator by x square, so I have to multiply by x square, so this becomes x alpha beta plus 2. Now the remaining log to the base e 1 plus x power beta. Okay, this whole thing is remaining. Now you see that this guy, okay, the written what I have written in green, that is not taking everything to 0, right? This is always a finite number. Okay, so what we need to do is we focus on rest of it and see how, for what value of alpha beta this would go to 0. You get that? Okay, so this is a kind of conceptual. Let's see. Now I will just skip writing this whole thing. Okay, I will just write the one which is going to take my limit to 0. So let me just write the complete thing. Okay, this is ln 1 plus x power beta. Okay, log to the base e and ln is the same thing, you understand, right? Okay, now here we have to understand that log function, okay, and a polynomial function, how are they comparatively behaving? You know that log function moves very slowly, like very slowly. As x goes, the y value moves very slowly. Okay, whereas the polynomial, this is just x, right? Still it's a polynomial. See how it is moving faster, right? Faster than this guy. How x square more faster, right? X cube more faster, right? This is how they move faster. Like I'm talking about large value of x, right? Okay, so for large values of x, that means that this is the term who is going to dominate. Okay, now you see this is sitting in the denominator. The moment I have this power to be positive, you see, so what I'm saying is the moment I have alpha beta plus 2 is greater than 0, do you think that this whole guy is going to drive the whole limit? Because this will go to infinity, everything should go to 0. We'll see how. Okay, so because that would mean that alpha beta should be greater than -2. Now for the time being, let's see which options are going to satisfy that my alpha beta is greater than -2. Which one? -3? No. -1? Yes, it is greater than -2. Here, -1? Yes, it is greater than -2. This again, no. Okay, so B and C are satisfying that option. Now let's see here. The first value looks for alpha. Okay, so if I look at the first option, limit x goes to infinity, what's happening? I have alpha value to be -1. Okay, so what's happening? If I bring everything to the denominator, it looks like this, right? Alpha beta. Okay, alpha beta is -1, so I get just x to the power 1. Okay, and ln 1 plus x, beta you're saying is 1, and alpha, so here also alpha is 1, so this comes in the denominator. You agree with that? I'm exploring the B option. Now, do you think as x goes to infinity, everyone is going to infinity? Yes, so this is going to 0. Good. Explore the C option also. Okay, C option says that limit x goes to infinity. Okay, but you have here ln x, okay, power alpha. Alpha is 1 here. And here you have also ln 1 plus x. Beta is also what? Beta is -1, so this comes on the top. okay, and x is alpha beta plus 2 is 1 only. Okay, so let's check. Okay, what is this limit? So this limit is limit x goes to infinity. Okay, shall we apply L'Hopital's? Yes. Okay, first function into derivative of second plus second function into derivative of first, okay, divided by derivative here. Okay, so you happen to get limit x goes to infinity ln x upon 1 plus x, this term. Okay, separate the limits. Okay, divide the limit with each one of them. Limit x goes to infinity ln 1 plus x upon x. Apply L'Hopital's once again. Okay, again because it is infinity by infinity form. So limit x goes to I'm just checking for you. Okay, we are actually done with the question. Okay, I'm checking that for you to realize yes, it is working. Okay, so 1 upon 1 plus x, and this is 1. Now as x goes to infinity, you see that this is also 0 and this is also 0. 1 upon 1 plus infinity, right? That's 1 upon infinity, which is 0, 0. Okay, so both are working. B and C both are working. So moral of this story was that this guy is going to tell you how you are going to 0. Okay, basically if it is having this positive power, then definitely you're going to 0, because log x is not significant with respect to a polynomial function. Okay, that is why this is driving the whole thing. Okay, okay, see with another question.